Good morning, guys. Whatever the JEE mains examinations of this session, making us to learn a great lesson. So that's going to be a bit lengthy and tough also. So that the cutoff mark is going to be lesser for almost all majority sections are going to be having like that. It's lengthy say questionnaire and tricky questionnaire and tougher one lengthy problems. So that is a hint to NEET also. It's going to give a greater hint to NEET because they are indicating that it is going to be a bit tougher exam. So that children, let us be cautious about the weightage of the topics. The chemical bond is going to be the versatile topic where the student can face at least 2 questions other than groups, etc. So that children, we are doing with chemical bonding, and in the past classes we have done the number of bonded pairs and number of lone pairs. The bonded pairs is nothing but sigma bonds, and lone pairs also we have seen. So number of sigma bonds or bonded pair and also lone pair that results in a different type of hybridization based on the number of bond pairs and based on number of lone pairs, children. Now, let us see, children, the hybridization Vosper as well as bond angle is concerned. In brief, we'll do in a shortest way. For instance, children, if the hybridization is going to be, see, suppose if you are having some hybridization, the hybridization is different, like sp, sp2, sp3. The bond angle also follows the sp is greater than sp2 is greater than sp3. So children, if the hybridization is going to be same, the bond angle is going to be same if there is no lone pairs. As the number of lone pairs increases, the bond angle is going to be decreases over here. See, let us go through the possible and decent examples, children. Suppose we will take NCl3, PCl3 and AsCl3. In all these cases, the 15th group elements are having one lone pair of electrons. The hybridization is going to be sp3 and of course sp3. People write like that, and of course it's going to be having. Whereas the central atom is going to have a smaller size. If the central atom size increases, the bond angle is going to be decreases. See this, children. In this case, the central atom size increases. The bond angle is going to be, what is happening, Baba, decreases. So that's the one case, Baba, here. And now we will see the example of AB3L also. This is AB3L, this is also AB3L, but here the case is different, children. See that? It's a very logical, simplest logical question. Suppose if you have seen this, no, the bonded atom size has been increased when compared to the central atom is going to be remain same. Are you getting? So when the bonded atom size increases, the bond angle also increases. So this is central atom. In all cases, the hybridization is going to remain same, Baba, because it's having one lone pair, sp3 only, followed or not. So that's nothing but whatever is called here sp3, but central atom size remains same. Central atom size remains same. But what is happening here, Baba? The bonded atoms, that's all going to be. But the bonded atom size increases. The bonded atom size increases. So when the bonded atom size increases, what is happening here? The bond angle also going to be increases. It's a very simplest way of learning this kind of one. And let's go through this. Sulfur dioxide. As far as sulfur dioxide is concerned, children. See, the hybridization on central atom is going to be remain same. But SO2 is going to have 1 LP of electrons. So that the SO3 bond angle is going to be greater than that of SO2 bond angle. So, because it is not having any lone pairs, but the hybridization remains same. See, Baba, here. In this case, a bit important also, seems to be a different question. on the carbon, the hybridization is going to be sp. But in xenon difluoride, the xenon hybridization is going to be sp³d, right, Baba? But they are linear as per VSEPR. Their bond angle almost all remains equal. Almost all remains equal. But in fact, its geometry is trigonal bipyramidal. Its geometry, shape remains same because having no lone page. Here, in this case, geometry as well as shape remains same because it doesn't have any lone page. But the geometry is here. sp³d. That means here, children, it's going to be trigonal bipyramidal. But the shape is predicted by VSEPR. It's going to be a linear shape. Both are linear and bond angle also. Almost all remain same. See that, Baba. Another very good example is concerned. When you have seen this, no, ICl2 minus 1, ICl2 minus 1 and ICl4 minus 1. See, here hybridization is different. See, different hybridization, sp³d, and this is going to be sp³d². When you have taken sp³d and sp³d². sp³d here, what is the shape of this one, Baba, here? sp³, don't pay this, just I am showing you. Once already we have seen this. It's going to be what's called here linear. In general, I told you, children, in sp³, the lone pairs are going to be extended to equatorial positions here. And in case of what you call as here sp³d², what is happening, children? The lone pairs are going to be extended to axial positions. The lone pairs has been extended to what's called here axial positions. So that's going to be what's called here ICl4. This is going to be ICl4. So what's happening here? This is going to be, let us see here. So that it's going to be one of the interesting case. So that it's going to be a square planar shape. That's going to be linear shape. But almost all, which is going to have more bond angle. It's going to have more bond angle. Right? So that this is what we have seen with respect to this, children. And now we will go through this. Seems to be very simple, Baba. NO2 plus hybridization is P, NO2 minus its hybridization is sp². Tell me, children, if the hybridization is different of the central atom, naturally the bond angle is also going to be more. But take this compound, xenon O3 and xenon O4. Then what is happening, children, here? Hybridization remains same, but here you are going to have one lone pair. That's why its bond angle is lesser than this. So that, children, what we learned is going to be the bond angle, VSEPR as well as this hybridization concept is concerned, and we have already learned the simplest form of this. Lone pairs, bond angle, and VSEPR. There is a possibility of a definite question in this case, children. So, like this, we will go next session for another one also. P-pi-D-pi bondings, P-pi-P-pi bondings. That's the very tougher angle. Generally, we leads to a little confusion at that bonding. So, where the P-pi-P-pi bond forms, where the P-pi-D-pi bonds forms, we will go through with the shortest, simplest trick. Thank you, children. Thank you very much. The next session will be covering that P-pi, D-pi bonding. Thank you, children. We'll go for another session.